Sorry about that. So my name is Isaiah Cifuentes. I'm currently a business major with a focus in finance and marketing. Still deciding what I want to do, but I'm also looking into sociology. Anyways, that's besides the point. My presentation is going to be on exoplanets. And first, I thought I'd start out by defining what an exoplanet actually is. An exoplanet is a planet outside of our solar system that orbit stars other than the Sun that are known as extrasolar planets. The discovery of these celestial entities, which vary in size, composition, and orbit, have fundamentally changed our knowledge of planetary systems outside of our own. In summary, planets outside the Milky Way, planets that take up the rest of the universe, pretty much. Um, these are just some topics that give the search for exoplanets meaning, the abundance and diversity of it, habitability in the Goldilocks zone. We're going to get more into that. Technological advances, search for biosignatures, understanding planetary information, and the possibility of extraterrestrial life. So, getting more into it, we're going to talk about the abundant. Give me a second. Okay. So for the finding of exoplanets have uncovered an incredible diversity and quantity of planetary systems within and beyond the Milky Way. We've discovered things like rocky planets, gas giants, and even planets in habitable zones, aka Goldilocks zone, which is places that are that can sustain the right temperature, the right sorry, atmosphere, the right atmosphere for habitable water. Um, These are just some examples of this diversity of special importance where exoplanets situated in a habitable zone, also known as the Goldilocks zone. I've already covered that. The quest for exoplanets has propelled notable technological progressions in observational techniques to find smaller, more Earth-like planets. Methods like transit method and radial velocity measurements have been improved. Researchers are searching the atmospheres for exoplanets of possible biosignatures or clues of potential life. These consist of substances like oxygen, methane, or other elements that, in specific ratios, may indicate the existence of living things. Exoplanetary systems provide information about the genesis and development of planets, important insights into the mechanisms leading to the planet formation and evolution that can be gained from observations of early planetary systems. Exoplanets found in the habitable zone increase the exciting possibility of discovering extraterrestrial life. Even though the hunt for life outside of our solar system is still ongoing, finding the answer to the age old issue of whether life exists somewhere else in the universe requires a thorough examination of exoplanets. So, we're just going to discuss some methods of detecting exoplanets. We have radial velocity method, transit method, and direct imaging. Radial velocity method is the basic idea to measure a star's back and forth motion caused by an orbiting planet's gravitational pull. Transit method, observing how a star's light dims when a planet passes in front of it, obstructing some of the star's light. And direct imaging, being the principle of direct imaging is to record the light that an exoplanet emits or reflects directly, without relying on indirect effects of the host star. Pretty much, these are all just observing the different formats in which planets come in, whether it's studying their atmosphere, studying the light, the heat, temperature, all of that. It falls under all the same curtain, you know. Next, I wanted to give some examples of exoplanets. Some of the discoveries include the NASA's Kepler Space Telescope, or I'm sorry, no, the Kepler 186, which was discovered by the Kepler Space Telescope. This was actually, if I'm correct, one of the first exoplanets in which we have discovered. We had thought that it would be habitable because it was around the same size of Earth, and although it's still unknown, it is orbiting a red dwarf star, and I think I have a picture on the next slide, so we'll get into that. Another example, which is a completely different type of planet, is a gas giant, which goes by the name Osiris, or HD 209458, but nobody wants to call it that. We detected it by the means of the transit approach. If we go back, observing how a star's light dims when a planet passes in front of it. The atmosphere was directly identified, making it the first exoplanet of that specific kind. The discovery of water vapor and other chemicals in the observations shed light on the exoplanet's atmospheric makeup. So these are just pictures of it. The one on the right is Osiris. It is obviously not a correct picture. This is just like an AI generated kind of thing, but as you can see, it is pretty huge. If that were the sun and that were the planet, sun being what, like 100 times the size of Earth. I hope that puts into perspective how massive the planet is. And then Kepler 186, which is the planet that is around the same size as Earth, is the one shown on the left. It doesn't look as habitable, but that's because Earth is made of mostly water. So we're going to go to the next slide. So the variety of systems discovered. Multi-planet systems. A large number of exoplanetary systems have several planets around the same star rather than being isolated planets. Kepler 90, similar to our own system, it was one of the first systems ever to be discovered to have 8 planets. Hot Jupiters is another example of a system that we have discovered. Though they are closer to their host stars than Jupiter, these gas giants planets resemble Jupiter. Due to its close proximity to its star, Pegasi b was the first hot Jupiter to be identified, which challenged earlier theories about planetary formation. 7 planets the size of Earth make up the TRAPPIST-1 system, some of which may be in the habitable zone. TRAPPIST-1, an exoplanet the size of Earth that is in the habitable zone, making it a target for research in possible life forms. I believe TRAPPIST is one of the highest hopes for being in an habitable zone. Obviously, it would be almost impossible nowadays to get there, but the search for life is never ending, and the search for an habitable zone is never ending. Um, so these are just an example. This is an example of a comparison of the TRAPPIST to our own solar system. TRAPPIST system having, well, we have the same amount of planets, but obviously Jupiter's not there, Saturn's not there. But yeah, this is just I think it's a cool comparison. So how exoplanets aid in the search for life, identification of potentially habitable environments, study of atmospheres, search for biosignatures, and the understanding of planetary conditions. Finding potential habitable environments, exoplanets are essential for locating celestial bodies that are in their host star's habitable zones. The area surrounding a star where conditions would be favorable for liquid water to exist, a necessary component for life as we know it, is referred to the Goldilocks zone. We've already covered that. Now, we are not sure if water is a method of survival for every living thing in the universe and if there are living things. But at least to our knowledge, this is the best hope of research, the best hope of finding a planet for us at least to survive on after Earth disappears, blows up. Um, the study of exoplanet and planetary atmospheres. Through the observation of exoplanetary atmospheres, scientists can learn more about their temperature, composition, and the existence of molecules that could be signs of habitability or perhaps life. Spectroscopy, spectroscopy, I'm sorry, which examines light traveling through an exoplanet's atmosphere, is frequently used to accomplish this. And chemical signatures, or occurrences known as biosignatures, have the potential to reveal the existence of life. The search for biosignatures in the atmospheres of exoplanets is focused on these specific bodies. Examples include molecules such as oxygen, methane, and others that, depending on how they combine, may indicate biological activity. I believe I covered it briefly, but biosignatures meaning body heat. Body heat could be one. Oxygen, hydrogen, things that our body emits, things that other living creatures might emit that give signs of life. Although we haven't received any, we believe with what we know and the research that we've done, it is most definitely our best chance. Now, lastly, exoplanet research advances our knowledge of the variety of environments that planets may dwell in. This information broadens the variety of situations in which life could exist and helps us improve our standards for habitability. And lastly, I just wanted to finish it off with my reasoning behind picking this topic is just to find more research on potential life forms out there. Obviously, we may have found some, we may have not. Only the government knows, like only the top shelf people know. but I thought it'd be interesting to do my own research and maybe put certain pieces of the puzzle together to see if I could figure it out on my own. Sadly, I have not figured anything out, but I do know a lot more about exoplanets. Thank you.